So for the last section, we're going to look at the transform of the periodic function. So a periodic function is just a piecewise function. So think about the heavy side that repeats, and it has a period of t. A lot of times in the past when we talked about periodic, we looked at sine and cosine functions and things like that, but these step functions can also be periodic. So let's look at the function e of t, and it's going to be 1 when t is between 0 and 1, and it's negative 1 when t is between 1 and 2, and the period here is t is equal to 2. So if I were to sketch that out quickly, then I have 1 up until 1, and then negative 1 up until 2, and then it just repeats the pattern. Or another example, I have a 1 from 0 to 3, and then it drops down to 0, and then it goes back to 1, and then it drops down to 0. So it's on in these periods, in these sections, and it's off in the other sections. So that function would be 1 less than 0 less than or equal to t less than 3, and 0 to 6, and then it repeats, so therefore it took till 6, so my period for this one is equal to 6. So we want to look at the transform of the periodic function. So our theorem is, if f of t is piecewise continuous, on the interval from 0 to infinity and of exponential order, and periodic, with period t, then this is what we're going to use. The Laplace transform of f of t is 1 over 1 minus e to the negative st, and that t is the period, times the integral from 0 to capital T e to the negative st f of t dt. So for these periodic functions, we're only going to integrate from 0 to t because that takes us one complete cycle, and this is what the integral is set up as. So I'm going to do one out for you. I want to find the Laplace transform of f of t when f of t is equal to 1 when t is between 0 and 1, and it's equal to negative 1 when t is between 1 and 2. So for this one, our period is t equals 2. So I want to set up the integral. It's 1 over 1 minus e to the negative st. Well, t in this case is that period is 2, so it's negative 2s. And then the integral is from 0 to 2, e to the negative st, f of t dt. Now, because this is a piecewise, that f of t, I'm going to break it up into two separate parts. So 0 to 1, that integral f of t is just going to equal 1. And then from 1 to 2, that is going to equal negative 1. So I need to integrate these. That first part, oops, drop my brackets up here. The first part, this is going to integrate to negative 1 over s, e to the negative st from 0 to 1. And for the second part, because of that negative 1, it's going to balance it out. So it's 1 over s, e to the negative st from 1 to 2. So when I evaluate it, when I plug in 1, I get negative 1 over s e to the negative s minus negative 1 over s e to the 0. And then for the second part, I get 1 over s e to the negative 2s minus 1 over s e to the negative s. So these back-to-back negatives are going to become a positive here. And I can kind of start combining things. There's not a whole lot to combine, but I'm going to start here. This 1 over s times e to the 0 is just 1 over s. And then this negative 1 over s e to the negative s, and this one combines to negative 2 over s e to the negative s. And then lastly, I have that 1 over s e to the negative 2s.